Hey everyone, welcome back to the Syntax Grid channel. In today's video, we'll be diving into random forest for classification. Random forest is one of the most popular and powerful ensemble learning techniques that combines the predictions of multiple decision trees to improve the accuracy of our model. If you haven't already checked out our previous video where we covered the full concept of random forest, make sure to do so. Let's get started. Explanation 1. Import libraries. First, let's start by importing the necessary libraries. We'll use pandas and numpy for data manipulation, matplotlib and seaborn for data visualization, and sklearn for machine learning. We'll be working with the random forest classifier for our model and grid search CV for hyperparameter tuning. Concept. Each library brings a set of functions that streamline specific tasks in data processing, visualization, and model building. 2. Load dataset. Now, let's load our classification dataset using pandas. The dataset will be a CSV file, and we'll use pd-read CSV to load it into a data frame. Concept. Loading data into a data frame allows us to easily manipulate and analyze the dataset using pandas' powerful functions. 3. Data preprocessing. In this step, we separate the features x and the target variable y. The target is the column we're trying to predict, while the features are the inputs for the model. Concept. Clear separation of features and target variable is critical for training supervised machine learning models effectively. 4. Train test split. Next, we split the data into training and testing sets. We'll use 80% of the data for training and 20% for testing. This ensures our model is evaluated on unseen data. Concept. Splitting the data helps prevent overfitting by ensuring the model's performance is validated on independent data. 5. Hyperparameter tuning. Now, we define a grid of hyperparameters to tune the random forest model. These include the number of estimators, trees, the maximum depth of each tree, and the minimum number of samples required to split a node and form a leaf. We'll use grid search CV to search for the best hyperparameters. Concept. Hyperparameters are external configuration settings that can significantly impact the model's performance, and tuning them optimizes the learning process. 6. Grid search. Next, we use grid search CV to find the best combination of hyperparameters using threefold cross-validation. This ensures the model generalizes well. Concept. Grid search automates the process of finding the optimal hyperparameter settings, ensuring that the model is well-tuned for the given data. 7. Best model. Once the grid search is complete, we retrieve the best model with the optimal hyperparameters. Concept. Extracting the best model configuration ensures that we use the most effective hyperparameter settings for our predictions. 8. Predictions. Now, let's use our best model to make predictions on the test data and evaluate its performance. Concept. Testing the model on unseen data is essential to assess how well it generalizes, which is the ultimate goal of machine learning. 9. Accuracy score. We calculate the accuracy of the model to see how well it performed. Accuracy is the ratio of correct predictions to total predictions. 10. Next, we visualize the confusion matrix to understand how well our model performed across different classes. The confusion matrix helps us see the true positives, true negatives, false positives, and false negatives. Concept. The confusion matrix is a diagnostic tool that breaks down the prediction results into true positives, true negatives, false positives, and false negatives. 11. Feature importance. Finally, let's look at feature importance. Random forest can provide insight into which features are most important for making predictions. This can help you understand the model better and potentially improve your feature selection. Concept. Feature importance helps in understanding the decision-making process of the model and can be used to focus on the most impactful variables. 12. Visualizing. As a final step, let's take a look at the first decision tree in the random forest. While random forest uses multiple decision trees, Visualizing one can help us understand how a single tree makes decisions based on the features. This is a great way to see how the model interprets the data. Concept. Visualizing a decision tree provides a tangible view of how the model makes decisions based on the features, even though the overall random forest relies on multiple trees. That's it for today's tutorial on implementing random forest for classification. We've covered everything from loading the data to hyperparameter tuning and evaluating the model. We also took a deep dive into the first decision tree to see how it makes predictions. Random forest is a powerful technique, and I hope you now have a better understanding of how to use it in your own projects. Don't forget to like, subscribe, and hit the bell icon for more data science and machine learning tutorials. Drop any questions or feedback in the comments below. I'll see you in the next video.